Rob, it's all yours.
All right, thank you. Um, so we've got, again, another kind of grab bag of topics. The design files and xddm for Cart3D optimization go together. The variable presets is kind of related. It's an interesting feature, and we'll spend some time talking about that. I'm Rob McDonald, and thank you all for joining us for this session of the VSP workshop. First, let's talk about some typical design workflows. Lots of times you'll use a VSP model as a baseline, and then you'll want to go and make changes to that model to try and design a better aircraft or a better model. And so you can do this lots of ways. You can do it through the API. You can do it by building your own models. But one of these workflows was so common that we added this design capability that I'm talking about today to try and make that easier. So the idea is, the first thing you want to do for a typical design workflow is you have to set up the design problem. And so that's done interactively. So the setup, you load or create a baseline file. Then you choose the variables that you're going to participate in your design study. You save a design file, and that writes out either a DES or an xddm file. And that sets up your design process. Then, in your design study, what you do is you modify that DES file. You make changes, and that's basically a template. You modify that, maybe you do it in MATLAB, Excel, Python, whatever you want to do. You modify that design file. And then from VSP's standpoint, the red boxes are VSP. You load the baseline file, the same baseline file is over here. You load the modified design file. You perform some operation. You generate a mesh, you do comp geom, you do a drag calculation, whatever you do. You perform that operation, and you get your result of your design. And that's the typical kind of workflow that you might do as an iterative that we're trying to support. It also allows you to do an inspection. So let's say you've done this design, and it's come through until you got to an optimal airplane. Now you want to look at that airplane. You want to see what it looks like. So in that case, what you do is you take your modified design file of your optimum, your final answer. Again, you load up the baseline file interactively. You load the design file. It applies those changes, and then you've got a normal interactive VSP session from there. And hopefully this will make a little bit more sense as we go forward. A little bit of an aside, Cart3D, which is a CFD package from NASA Ames, has an adjoint-based design capability built in. And in that design capability, that part was really developed by Marian Nemec. Marian developed the xddm format as a way to describe the optimization problem. So that's how you tell Cart3D what the variables it can vary and the min and the max values for those for optimization. And I think xddm means XML design data model, I think. No, it's right there, extensible design description markup. So this is just a Cart3D special format, but it contains the same information as the design file. And it contains, these elements of a variable, a constant analysis, all this information for Cart3D, and some other things that go with it. And so VSP now has native support, and has for a long time, for Cart3D shape optimization. So it makes it trivially easy to use VSP as the geometry engine in a Cart3D optimization study. And it just does what you want it to do. So that's fun. So like I said earlier, to do this, you go to the model menu and you choose design variables, and that loads up the design variable GUI. And for a particular design study, what you're going to do first is you're going to choose which variables you want to work with. And so you can use the pull downs, or you can drag and drop, and you just pick. You say, okay, I want to vary root chord, span, sweep, tip chord. You add those to the list, and it's just that easy. You've set up a design problem. After you've chosen them, well, here's that just zoomed in. You can pick on the top. You tell it whether it's a variable or a constant, which is an xddm flag. You can add or just drag and drop. And then down here at the bottom is where you save or load that file. And you either do an xddm file or a DES file, and then you save that file. The other tab, when you pick those 4 variables, that gives you just a handy place where you can go and you can adjust those right here without having to go anywhere else. So you can also use this as a way to just pull, if you've got 5 variables that you love to vary on a particular model, and one is on an engine, one's on a pod, and one's on a tail, you don't want to have to go searching around for them when you're presenting to your boss. So you can just come in and consolidate those in one place to make them easy to find. The design file, the des file, is just this incredibly simple text file. The first line is the number of variables. Then each line, there's 1 per variable. It starts with a unique ID that comes out of VSP. It's all caps. It's probably 11 characters long, maybe. And that's a random generated ID that you don't want to change. That is what VSP uses to uniquely identify the variable. After that is the human readable name that goes with the component name, the group, and the parameter. So that's that hierarchical name that we work with. And then after that, there's a final colon with a space, and then the value, the number. This is a very simple file. If you're doing a design study in MATLAB, what I would do is I would set it up so that it just prints these 5 lines with whatever numbers you want as the final bit. And that's all you have to do to write a design file, a des file. xddm is the same idea, but it's Merriam-Webster's format. It's an XML, so it's a little bit, it has a lot more greater than and less than signs in it. This is how it gets set up. Here on the left, there's an ID, and this ID is the name that Cart3D is going to name it, and the optimization framework is going to name it. We default that to the component, group, and variable name. That's probably more verbose than you want. It's a big, ugly name. So you may want to trim these down and edit them. So change it to whatever you want. Call it just chord, span, sweep, and tip, or whatever you want. You can change these. However, over here's the VSP ID. These are that random number, that random letter ID that we use internally in VSP to uniquely identify the parameter. Don't change these because then it won't work. So this is what VSP uses to uniquely identify the parameter. This is just a label that Cart3D and the optimization framework uses to report out to users what's going on. Once you've done that, you can now access these from the command line for your optimization study. So for example, if you run VSP with the baseline file, airplane.vsp3, and you want to run a script, whatever your script is, it will, this is the command line help that VSP sprints out. So if you want to just write out a Cart3D and unintersected try file, that's actually just a 1-line script. I mean, 5 if you count the comments and things like that. So you just have to have a main with export file, the output.try 0 is the set all, and then what type is export Cart3D. And this script, if you run it as the script, will output that file. Likewise, if you want to run compgeom and then export, it's 2 lines, or if you want to run CFD mesh, it can just be 1 line with all the exports set. And you can use that and apply it with a des file or an xddm file. Changing gears a little bit, there's this concept of variable presets. And presets are a neat technique where you can have a single model that now has multiple states in it. And it's different versions of a single model, but all in one file. So certain things can't change, right? It's going to have the same number of fuselages, the same number of wings. They're going to have the same names. They're going to have the same number of cross sections, the same airfoil types, the same exec types, right? So that level, the topology of a model stays the same. But the values of the parameters, anything you can move with a slider, they can be different. And that's the state difference. And you can use this for all kinds of things. For example, if you have articulation in your model, you can have different states of articulation. So you can have a gear up model and a gear down model. If you go to the trouble of modeling flaps, you can have a flaps down, flaps up, and you can have different flap positions. You can have takeoff versus landing deployment. You could have your wings folded and deployed, tilt rotor or variable sweep in different positions. So those are all articulation things that'll be different states. You can also make different tweaks for different analyses. For example, maybe you run 2 2 different analyses, 3 different analyses, and you want to use different mesh resolutions for these. So you can have one state which is sort of set all of the tessellation parameters to fine, and another that sets all of the tessellation parameters to coarse. And you can very easily switch back and forth between your fine model and your coarse model, or your medium model. Another use is when you're doing a design study. In any sort of design study, you're going to have a baseline model, but after you've completed the study, you might save as a preset your answers, and you might have multiple answers to an optimization study. You might have a minimum mass, minimum gross weight vehicle. You might have a minimum fuel burn vehicle or a minimum cost vehicle. And using variable presets, you can very quickly switch between the different versions of your answer. You can also use it for a family of airplanes. And depending on how detailed your model is and how simple it is or how you set it up, you could just do a variance of a family like a 737-7-8 and -9 and have one model that represents each of those. You could probably, not in super fine detail, but you could probably also do a single model that represents most twin engine transports, whether they're Boeing or Airbus or a Sukhoi or a Comac, and you'd be able to capture most twin engine transports with a single model that gets pretty close just by varying some of the parameters. So these are all different things you can do with variable presets. And again, this is a power feature. You'll know if you need it, and it'll really enable you to do some cool things as we go forward. The way it works is variable presets operates on groups of parameters. And so you're going to group the parameters into something like landing gear or mesh resolution. You're going to give it a name. So a group is named. You get to pick the name. And then there's multiple parameters in a group. So if you have landing gear and its articulation, you're going to have one that rotates the nose gear and a different one that rotates the main gear. So you've got multiple params in a group. And of course, params could be in multiple groups, but that probably won't actually happen. So you've got groups of params, named groups of params, and then you have each group gets different settings. So if it was a landing gear, the obvious settings are going to be up and down, and they get names. If they're flaps, then you might have cruise, takeoff, and landing as the 3 settings that are named. To set one of these up, the general workflow is you first add and name a group, then you add and name a setting to that group, and you pick what parameters you want to be in the group, again, either through the pull down or through drag and drop. And then you can add more settings and give other sets of names. So you can rotate through that to set it up. Once you set it up, it's really easy to work with, in that if you want to switch, you just come back to the variable preset menu and you say, which group do you want to switch? Do you want to switch landing gear or resolution? And you want to then apply your set. You pick which setting you want. I want to set my landing gear to takeoff or to cruise, and then you hit the apply button and it sets all those parameters. So that's how the workflow works. To get to it, you go under the model tab. You pull down variable presets. Right now is the last one on the list. So you choose the variable presets menu. It pops up like this. This top part, this very top part, is where you, if you're just coming to switch models, this is where you pick the group and the setting and you hit apply. So this is where you work once you want to change the parameters. Everything down here is more for setting it up. So you can create or adjust the values. So here's where you can add a group, then you add the settings and you pick what variables are in it and you set that all up. So with that, I've got time for a little bit of a demo. I can do both a design flow demo as well as a variable presets demo. If there's any questions that are coming up, Brandon, you can ask them and I'll try and answer it as I go.
Okay, there was a question that did come up that says, can you use variable design files to change mass properties directly from MATLAB, or presumably with any editor?
On the third day of the workshop, Thursday, I guess, Justin will be giving a talk about using MATLAB from the API, so you can really talk very directly So that's a pretty advanced thing. You can certainly do that. You probably, I think a lot of people don't need to go that far. And what I would do is I would just use the design file, and I would, like that example I showed earlier, it's just 4 printf lines, and so you'd have your MATLAB script with 4 lines of printf, dump out that file with whatever values you want for the variables, save that file, and then you can then execute VSP using the system command to run an external program. And so that's probably how I would do it from MATLAB. Let me just do a little bit of a des file demo. So here's the default wing. And if we're only working with the wing in our design study, we come here to our design variables menu. And here's the design variables thing where we get to pick this GUI where we get to pick what variables we care about in our design study. So in our design study, for example, maybe we care about the span, the root chord, the tip chord, and the sweep angle. So what we do is we just drag and drop to pick which variables we care about. As I said, they all get added to this adjust menu. And so I can come in here and I can change those all from this one place. And that just consolidates them. If, once you've done a study, you want to come in here and you don't have the component open, you can still vary these. Down here at the bottom is where you save or load that file. So let's save this. And actually, before we do that, let's save the airplane. So we're just going to save it on my desktop as our desvar demo VSP3. So we just save that file. And now we want to save, we're going to save a des file. So we're going to do test des and we'll accept. And we'll also do the xddm. Whoops. Let's change it to the xddm, and we'll do test. And we'll call it test2, even though it's going to give it the xddm name. So, here we are, VSP's loaded. We could quit if we wanted. We could do this from the command line. But what I'm going to do is I'm going to come over here, and I'm just going to open this des file with a generic text editor. I like TextMate. And so we'll open it up. And like we said, there's 4 variables. We've got this random string that identifies the variables uniquely. This is the label that tells me what it is, and then here's the values. So let's change our tip chord to 3.5. Let's change our sweep to 22.5 degrees. Let's change our span to 12. Let's change our root chord to 5. And again, however I write this file, whether I'm going to just hit save. So I've now modified this file. However I write this, whether that's 5 lines of printf in MATLAB, or whether that's out of an Excel sheet or Python, however I do it, I write this file. In VSP, I can load this on an automatic way from the API. But to just show you what happens, we can also do it interactively. So this is that third column of that workflow. We can just come and we can hit the load button. And we choose, we are loading an xddm. Instead, we want to load a des. So we load a des, and there's our file that we modified. And as soon as I hit accept, you're going to see this model update. So I'm going to, let you see that. But here we go. We hit accept, and the model updates. And if we come look at the parameters, they're exactly at whatever I set in that file. So that's a typical des workflow. We'll look real quickly at the xddm file just so that you can see what it looks like. Conceptually, it's the exact same thing. It's just, instead of in a simple text file, it's in Marion Nemec's XML format. So this is, you're only going to use xddm if you're a Cart3D user. Everybody else use des. But if you're a Cart3D user and you like to do shape optimization, then here's where you can control that. Again, here's the values of what we set them to a minute ago, the min, the max, the unique ID. Again, we can come in here and we can change this to anything else. So if for our study, we want to shorten these names down to root chord, span, sweep, and tip chord, that's a very reasonable thing to do because it's much more human legible. Here we can change our values to anything we want. So let's make the root chord be 1. Let's make the span be 3. We'll make the sweep be minus 16. And we'll make the tip chord be 0.8. And we'll leave everything else alone, but we'll just hit save. And coming back in here, just like before, if we could switch to xddm and we load that up, it's going to modify that model to whatever we had. So that's a couple of design workflows. The other one that we talked about here was variable presets. So this is kind of related. What you do is you come into the model. The last option is variable presets. And again, what we're going to do here is we're going to set up 2 groups. So first, let's set up our group, and we'll call this our study variables. We're doing a design study, and we'll call it our study variables. And our first setting is going to be the baseline, and we'll add that. And so now we can come and we can choose what are our variables. And just like last time, we're going to pick span, root chord, tip chord, and sweep. And the values, if we do this right now, they are what they are. If we come in here and we adjust them, really what we want for our baseline, we'll say is a root chord of 4, a span of 9, and a tip chord of 1. And that's the default VSP wing. And we just changed it, so we're going to save the changes. This button, that's going to apply that to our baseline. So when we hit save, it grays out. What we just did is we just updated our baseline. So now our baseline is the baseline wing. And what we're going to do here is we're going to make a fast answer. So when we come in here to what fast means, we're gonna make this look like a fast wing. So we want more sweep, and maybe we even want to go like a delta, something like that, and we want a lot less span. So we're gonna really increase the sweep here. There we go. That looks like a fast airplane to me. So we're gonna save that because that's fast, and we're gonna come back over here, and we're also gonna create slow. And, a slow airplane, if we want to come over here and adjust it, well, that's going to have no sweep at all. And it's going to have a root chord and a tip chord that are the same. And the span is going to be about like that, maybe a little higher, 12. So we've got a nice high aspect ratio Hershey bar wing. So that's our slow airplane. And that's how we created our study vars. But we also wanted a different group. So we're going to create a group that's resolution. We're going to add that, and here we're going to have our baseline, and we'll add our baseline, and it's going to have num-u and num-w, and that's set up as the baseline, so we're fine with that as is. We're going to create fine, and for fine, we just want to come over and say, you know what, we need these to both be a lot bigger. So we're going to make that resolution really fine. We're going to make this resolution really fine. So that's fine. We're going to hit Save Changes. And we'll also create coarse. And we'll add coarse. And again, we'll come in, we'll adjust to whatever we want coarse to be, but we want it to be really coarse, right? Something really, really chunky. And we'll save changes. So now what we have is, and we can come back to the create tab, it doesn't matter, but we're only going to work now that we've set up our variable presets. And again, these get saved to our model, so we can hit save. Now our model has different states memorized. And so, for example, if we want to go to the baseline resolution, you just choose which group and what setting, and you hit apply. And likewise for our study vars, if we want to look at our baseline study vars, we look at that, and we've got the baseline resolution with the baseline wing. And if we want to change our resolution to fine, then we just change that group and change our setting and hit apply. And likewise, we can look at the study vars slow airplane and look at it fine. And you can just very quickly jump between whatever group and whatever settings you want to apply for variable presets. I think that's probably enough of a demo. If there's any questions, we've got maybe 3 minutes for questions before we need to start the last talk for the day.
Okay, thanks, Rob. We had somebody send a message here asking if, when you're using the design variables, if you add multiple component masses together to get a total mass, would you either control the total mass or the incremental masses in the des script? So, for example, the wing itself plus something that's electrical or hydraulic.
So that's more a question about how masses work in VSP.
Yeah.
If we come into the wing geom, we don't have a talk on mass properties, but VSP will calculate the mass properties for you based on the shape, and it'll have two terms for each geom. One is a volumetric based density, and that's what you think of normally as density. And here it defaults to 1, but we could change that to 5. And again, the units are going to be whatever you think they are. So if your model's in feet and you want the mass to be in kilos, then this is going to be kilos per cubic foot. So that's 5 kilos per cubic foot. That seems like or kilos per cubic feet. Well, that's what you want it to be. That's what it is. So that's the volumetric density. There's also, you can turn on the thin shell. So any part of the exterior shell, and it's only going to use the shell that's actually in contact with the flow, the wetted surface. So if you have a thin shell, you could use that, and then you're giving a mass per area. So think about this: if you had something like a foam core composite wing, you'd put the foam density in the volumetric, and you'd put the composite layer on the shell. You can then also have other components like this pod. So for mass properties, one way to go is you come in here to mass properties and you say compute. And what this actually just did was it created this text file that shows, here's the mass breakdown, the totals, the center of gravity, the moments of inertia of this geometry, using those densities and surface areas and intersection for the mass properties. So in this way, mass properties is an output, not an input. And that's how we usually think of it in VSP. That said, if you want to treat it as an input, you could certainly, first off, you could have this density as an input that you vary with desvar. So just as I dragged and dropped in design variables, this density could be one of those variables that gets varied. You also could do a blank component. There it is, blank, where you can then attach that to the wing, or say you have a complex model of an internal combustion engine, you could then attach a blank model to it, and then come over here to mass, turn on the point mass, and drag that down, because you've got a complex model of an internal combustion engine. You don't want to trust VSP's estimate of the mass. The manufacturer tells you that it weighs 167 pounds. You just want to come in here and type in 167 pounds. And so you can drop that point mass in and set the density of the engine and the other components to 0. And now with that point mass, yes, you can vary that mass from a design variable. You can change that engine's point mass from a design variable. And that's a place where mass could be an input for a design study. And I hope that answers your question.